So the acceleration vector is the derivative of velocity. So the velocity vector, which is just dx dt and dy dt for its components. So to take the acceleration, get the derivative of velocity, you get the components 0.396 and negative 0.741. So on the calculator, storing the derivative of x with respect to time as f1 of x and derivative of y with respect to time for f2 of x. Those are the components for the velocity. To get acceleration, we're going to have to do the analyzing the graph, get the slope. So dy dx for the x component is 0.396, and then to get the dy dx for the y component is negative 0.741. Then we need the speed, and speed is just the magnitude of velocity, which is the square root of dx dt squared plus dy dt squared. So speed is the magnitude of velocity, getting the magnitude at the value of 2. So that's x prime of 2 squared plus y prime of 2 squared, which comes out to 1.208. So in the calculator, just typing in the square root of f1 of 2 squared plus f2 of 2 squared to get that value of 1.208. To get a vertical tangent line, that just means that the slope will not exist. And that means that dy dt over dx dt is going to be some number divided by 0. And so that means that the dx dt is going to equal 0. So just taking dx dt, setting it equal to 0, solving in the calculator to get time is equal to 0.693. So numerical solve, taking that dx dt component, which was f1 of x, set it equal to 0, solving for x to get 0.693. Slope of a tangent line is just dy dx, which is the dy dt over dx dt. So m of t is just dy dt over dx dt. Then to get the limit as t approaches infinity of m of t, the dy dt is just going to be 0. The degree of the numerator is less than the degree of the denominator. And then substituting infinity for dx dt, e to the negative infinity comes out to 0, so that's going to be 1 minus 0, so sine inverse of 1, so that's going to be 0 is our answer. So for a horizontal asymptote at y is equal to c, that means the limit as x approaches infinity of f of x is equal to c. So just looking at a sketch of the graph of a horizontal asymptote at c, as x goes to infinity, y goes to c. So that means the limit as t goes to infinity of x of t is going to be infinity, and the limit as t goes to infinity of y of t is equal to c. So then the limit as t goes to infinity of y of t is just going to be the initial y value, plus the integral starting at 2, because that was our initial time, to infinity of y prime of t. The initial y value was negative 3. Then plus the integral from 2 to infinity of the y prime of t dt, and that's equal to the value of c.